What if I told you rockets are about to become useless because Japan wants to replace them with a cable that reaches space? And if it works, every satellite launch industry collapses. Not a rocket, not a launch pad, a cable stretching from the middle of the Pacific Ocean all the way to geostationary orbit. And they've already chosen the company to build it. Here's why this changes everything. Every time we send something to orbit right now, we light $5 million worth of fuel on fire. Most of the rocket, destroyed. Every single time. That's not an engineering flaw. That's just the only way we've known how to do it, until now. What if instead of burning a rocket, you just rode a cable straight up? This isn't a YouTube concept. This is Obayashi Corporation, the company that built Tokyo's tallest tower, and they want to do the same thing, except into space. Their plan, a 96,000-kilometer carbon nanotube cable, a floating ocean terminal, a station at geostationary orbit, and a 2050 target. The elevator runs on electricity. No fuel, no explosion, no hardware destroyed every launch. There is one problem. The material that makes this possible. It hasn't been invented at scale yet. But right now, on the International Space Station, Shizuoka University is testing it. That single test sample is the only thing standing between a concept and a construction site. Here's exactly how they would build it. It starts in a shipyard. Workers plasma-cut 40mm steel plate, curved, precise, massive. Each plate bent to the exact radius of a 400-meter floating ring. 24 watertight compartments, every one flood-tested before the next one begins. One leak, and the whole port sinks. Section by section the ring grows, each joint aligned to within 2 millimeters. Underwater welders seal the base. That weld has to hold at sea for decades. Inside the hull, ring frames every 2 meters. Ballast concrete poured into the base. 48,000 tons just to keep it from tipping. From the inside, it feels like a submarine. That's exactly what it is, designed to survive the equatorial ocean for 100 years. 12 thruster pods fitted to the hull. These steer a 400-meter ring through open ocean. A 60-meter steel lattice tower rises from the center. Power cables threaded through the legs. Sensors on every surface. If the cable vibrates, every movement is measured from the first second. The climber loading dock goes in next. Guide rails, locking arms, built for a 100-ton vehicle docking at sea. Everything on this platform exists for one purpose: to grip that cable when it comes down from orbit and never let go. A full city runs beneath the deck. Desalination, power generation, sewage treatment, 6 generator sets below the waterline. This port cannot lose power, ever. Now for the part nobody talks about. The cable itself starts in a CVD reactor, growing carbon nanotube fiber, atom by atom, drawn off the reactor onto a drum. Uniform, continuous, defect-free. Or it starts again. Fibers twisted into yarn, yarns bound into ribbon, polymer matrix pressed through heated rollers. Then a protective coating deposited on every surface, because without it, radiation strips the carbon bonds in months. Every section imaged under electron microscope. A gap in the coating is a gap in the cable's life. 20 tons of this. That's the seed cable. It weighs less than a truck. It has to hold more than a skyscraper. Each spool sealed in nitrogen, because oxygen degrades the ribbon. It travels in inert gas all the way to the launch pad. One rocket. 300 tons of liquid oxygen. The cable rises on a column of fire. First stop, geostationary orbit, 36,000 kilometers up. Separation. Thrusters fire. The spacecraft orients. And then the spool starts turning. Ribbon feeds out, down toward Earth, up toward the counterweight. The ribbon is thinner than a human hair, falling 40,000 kilometers. On the port below, the capture crew is at stations. Days of watching. Then the ribbon enters radar range. An aircraft snags it above cloud. Workers lower it to the deck. The ribbon touches the Earth port for the first time. One guide roller at a time, workers thread it into the tensioning drums. Tension applied. The ribbon goes taut. From the Pacific Ocean to geostationary orbit. One continuous structure. the longest thing humans have ever built, and it took one rocket to put it there. But a seed cable can't carry cargo. It has to grow. 510 reinforcement climbers. Each one carries a full spool of ribbon. Load it, close it, send it up. Inside every ascending climber, a bonding head presses new ribbon onto the cable, layer by layer. A weak bond, the climber stops, redoes the section, comes back down, gets serviced, goes back up. A satellite crosses the cable path, port thrusters fire, the ribbon swims clear, then returns to station. After lightning strikes, the ground strap is replaced. Workers have a spare ready every time. It's a consumable, not a catastrophe. At year 6, the factories retool for wider ribbon. The cable is finally strong enough to carry the heavier spools. At year 14, they run final thickness ribbon. By year 15, the first real cargo goes up. Not reinforcement ribbon. While the cable grew, the GEO station was being built on Earth, module by module, then flown to orbit by rocket. The irony isn't lost. Rockets building the thing that replaces rockets. In orbit, construction climbers hold position on the cable. Robotic arms bolt the frame sections together. Workers climb to GEO by cable, fitting internal life support by hand, in microgravity on 8-day shifts. Solar arrays deploy panel by panel. The hinges release and lock. Station complete at 36,000 kilometers. Workers have built a city in space. The first crew returns by cable. 8 days up, 8 days down. The first passenger climber is fitted out. Seats, life support, viewports. This one carries people. Day 1, through the atmosphere. Day 3, Van Allen belts. Day 8, GEO. The docking arm reaches. Latches engage. Hatch seal confirmed. And for the first time, a passenger walks from the cable into the station. $10 per kilogram to orbit, against 2,720 today. That number changes everything. No rocket, no flame, no noise. A satellite going to orbit on a cable, powered by a laser beam, built by welders and ribbon workers and control room crews, one bolt at a time. 96,000 kilometers, the same tools, the same hands. Japan imagined this on paper. The engineering is already real.